everyone, and welcome back to Caroline's Chemistry. Today we're looking at calculating gas volumes, a really important skill in GCSE Chemistry and one that comes up a lot in exam questions. We'll go through the key ideas you need to know, work through examples together, and make sure you understand how to apply the formula to different problems. By the end of this video, you'll feel confident tackling gas volume calculations on your own. If you find this helpful, don't forget to hit that like button and subscribe so you don't miss any of my future videos. And let's dive in.
So here's the first thing to know about gas volumes. It is that the volume of 1 mole of any gas occupies a volume of 24 decimeters cubed. And that specifically is at room temperature and pressure, which most of the questions given to you will be at, especially at GCSE. So therefore, our equation can be that gas volume is equal to 24 times by moles. If you find it difficult to rearrange an equation, then you can use the triangle method. So you simply cover over which item it is that you are trying to find out, and then read off what the equation is. So cover over, for example, moles, and that means that you do volume divided by 24 in order to get the moles. Little note on the units, so there are standard units here of decimeters cubed. If you have to convert, then there are 1000 centimeters cubed in 1 decimeter cubed. Okay, let's dive into using this equation now. So these examples are starting off nice and simple and working a bit harder as we go. So let's start off with the equation. So volume is equal to 24 times moles. Now here the question quite handily just gives us the moles. So we can plug that right in. We do 24 times by 0.25 and that gives us 6, but that's not our final answer. We have to put in the standard units of decimeters cubed. So now what is the volume of 10 grams of hydrogen H2? Starting off by calculating the moles this time, because we are given a mass, 10 grams. So moles is equal to mass divided by the MR. So let's plug in those numbers. The mass is 10 grams, that's our standard units, that's fine. The MR of hydrogen, we look at the periodic table and its relative atomic mass is 1. We have 2 of those, so we times that by 2. So 10 divided by 2 gives us 5 moles. Now let's plug it into the volume equation. So we do, the volume is equal to 24 times the moles times by the 5. So our overall answer comes out as 120 decimeters cubed, not forgetting the units. So some extra steps here now. What volume of oxygen reacts with 1.2 grams of magnesium? We're going to start off with the same method that I teach throughout this topic. You can go back and look at the previous videos for reacting mass calculations if this is unfamiliar to you. Step 1 is about deciding what your tick and question mark is. So we know something about the magnesium. That's our tick. I'm going to set up a little table here of mass over Mr. Moles and put in what we know about the magnesium, 1.2 grams. The second stage is to work out moles of the tick. So we're going to work down the column here. The MR, or the AR I should say, of the magnesium as an element is 24. To work out the moles, we do mass divided by the MR is equal to the moles, and that therefore gets us to 0.05. Now we need to work out the moles of the question mark. So the question is asking us what volume of oxygen reacts. So oxygen is our question mark. In order to switch columns, we're going to use the big numbers in the equation. So the magnesium has a 2, the oxygen has no number, so it is a 1. So it's a 2-to-1 ratio. So we take this number and divide it by 2. And that gets us to 0.025. Now, at this point, I don't have to go back up the rest of the column because I'm not trying to find out the mass of oxygen. I'm trying to find out the volume. So instead, I'm going to plug it into our volume equation. Volume is equal to 24 times by the moles, 0.025, and that gets us our answer of 0.6 decimeters cubed. So let's start with the same method, so identifying our tick and question mark. Now we know something about the ethane that becomes our tick. We have 6 kilograms of it, but for my mass, I'm not going to write 6 kilograms because the standard units for mass is grams. So I'm going to convert that into grams first, so I have 6,000 grams of ethane. I'm going to work down this column now to work out moles. So mass divided by MR is equal to moles. The MR of the ethane, we have 2 lots of 12, not 16, 12 for the carbon, plus 6 lots of 1 for the hydrogen. So that MR there is 30. You do 6,000 divided by 30, which gives us 200 moles of ethane. Now we have our moles of ethane. We're going to look at what our question mark is, and we're asked to find the volume of carbon dioxide. So that's our question mark. In order to swap column, let's use the big numbers. So if the ethane has a 2, the carbon dioxide has a 4, so that's a 2 to 4 ratio, which is the same as a 1 to 2 ratio. So I'm therefore going to times that by 2, which gives us 400 moles of carbon dioxide. As before, I'm now going to use the volume equation. Now we have the moles. So 24 times by the moles, 400, and that gives us our overall answer of 9,600 decimeters cubed. Let's have a quick look now at some common mistakes. So the first one with any calculation, don't forget units. This isn't maths, it's chemistry, which means these numbers mean something. Make sure you include the units on your final answer. The next way to perhaps get caught out is standard units. So for instance, the moles equation uses mass in grams. The volume equation uses a volume in decimeters cubed. So if you have a unit conversion, and you might not have with every single one, do that before you put the numbers into the equation, not afterwards. And then finally, show your workings. Again, this is chemistry and not maths, which means each of these numbers actually has a meaning. It's the moles of magnesium, it's the volume of oxygen, etc., etc. So label each line of calculation with what exactly it is that you mean, so that the examiner can clearly see and easily award the marks for your great work.
Thanks again for watching, and if this was helpful, hit subscribe now so you don't miss a video, and let's ace your chemistry GCSE or A level together. I'll see you in the next video.